In the rush to integrate generative AI, many organizations have made fundamental architectural errors. They treat every user interaction as a tier 1 problem. We are routing simple queries, password resets, basic greetings, and navigational questions to the most expensive, most computationally heavy models on the market, like GPT-4o or Cloud Sonnet 4.5. In financial terms, this is equivalent to flying a private jet to pick up groceries. As you scale to 100,000 or a million users, this linear cost model becomes unsustainable. Your margins erode exactly when they should be expanding. And the solution isn't to stop using AI, the solution is intelligence tiering. Today, I'm going to show you the solution. It's called hybrid router pattern. It's an architecture that allows you to slash your API bills by 60 to 80%, guaranteed 100% data privacy for sensitive clients, and crucially break free from the vendor lock-in. Now, in my last video, I demonstrated how to run Llama 3 locally on your own hardware. The response was massive, but I noticed a concerning trend in the comments. Many of you asked, does this mean we move 100% to the local models? The short answer is no. That would be a strategic trap. We need to be realistic about the state of the art. The local models like Llama 3 and Mistral are incredible for privacy and cost, but they still lack the world knowledge, the nuance, and the complex reasoning capabilities of the massive trillion parameter cloud models. If you force your engineering team to use only the local models to save money, you will degrade on the user experience. Your chatbots will hallucinate more and they will fail at the complex reasoning tasks. You will save money on the server bills, but you lose on the customer churns. The winning strategy isn't local or cloud, it is hybrid. You don't fire the cloud, you demote it. You treat GPT-4 not as a default but as a specialist. So what does this hybrid architecture actually looks like? We need to move away from the flat architecture where your app talks directly to the API. We need to insert a middleware layer and we call it an intelligence router. Think of it as an air traffic controller. It sits inside your infrastructure. Every time a user presses enter, it intercepts the message and analyzes the intent. It doesn't just look for the keyword, it looks for the context. It uses vector embedding, the mathematical representation of the meaning, to understand what the user wants. And based on that, it makes the routing decision in milliseconds. We typically do this in 3 distinct tiers. Tier 1 is the compliance tier. Router detects your PII, medical data, or legal secrets. It routes it strictly to your local model running on your own VPC or on-premise server. What is the cost? Only your electricity consumption and 100% privacy guaranteed, no data leakage. Tier 2 is the efficiency tier. Router detects your routine tasks like summarization, translation, and basic Q&A and routes it to the economical fast provider like Llama 3.2 on Grok. It will cost you a few pennies, but the speed is instant. Tier 3 is reasoning tier. Router detects high complexity tasks like math, advanced coding, or strategic writing, and it routes it to GPT-5 or Gemini 3.5. Here the cost is high and the value is also high. Why should you invest engineering hours into building this? I see 3 massive ROI drivers. Margin expansion. The first one obviously is the cost. By decoupling 80% of your traffic to tier 2, you decouple your cost from your growth. You can 10x your user base without 10xing your OpenAI bill. The physical firewall. Second one is the compliance. The enterprise clients are terrified by the data training the public model. But with the router, you can contractually guarantee that the sensitive data never leaves your secure perimeter. You are not just promising the privacy, you are architecting it. Third one is the vendor leverage. This is the one most leaders miss. If you are hard-coded to OpenAI or Google, you have zero leverage. If they raise the price or change their terms of service or have an outage, you are helpless. But if you build a router, you are model agnostic. You have built a platform where models are just swappable batteries. We are moving towards a world where intelligence is a commodity. The value of a company isn't in calling an API, the value is in orchestration of the intelligence. Now I know what engineers watching these are thinking. This sounds great on whiteboard, but how do I actually build it? How do I handle the latency and what libraries do I use? This is exactly what we are doing in the next video. In part 2, we are going to build the exact router from scratch using Python. We will use the semantic router for brain and light LLM for connection. We will simulate the data lake and watch the router catch it in real time. So if you are an executive, send this video to the engineering lead, and if you are an engineer, make sure you are subscribed so that you don't miss the next installment. I'm Neeraj and see you in the next.